Chapter 9 Thermochemistry Exercise 9.61. A silver block, initially at 57.4 degrees Celsius, is submerged into 100 grams of water at 25.3 degrees Celsius in an isolated container. That means there's no heat loss or heat gain for the mixture of silver and water. The final temperature of the mixture upon reaching thermal equilibrium is 27.1. That makes sense. You can see the temperature of water increases, the temperature of silver decreases. That's just because heat flows from silver to water. The specific heat capacities for water and silver are given here, 4.18, 0.235. You can see this value is nearly 20 times this value. That means the temperature change of water should be much smaller than the temperature change of silver. And we can see that here the temperature change of water is less than 2 degrees Celsius, and the temperature change of silver, if you look at these two values, take the difference, it's more than 30 degrees Celsius. So it makes sense. What's the question? Part A, what's the mass of the silver block? Alright, so we don't know the mass of silver block. So how do we tackle this problem? Well, here's the thing. The heat loss of the silver becomes the heat gain of the water. If we look at the silver and water as the system, then Q should be 0 overall, right? Because heat flows from one part of the system, that's silver, to just another part of the system, which is water. And overall Q for the entire system should be 0. So now let's set it up. Let's look at the amount of heat flows into the water, which is pretty straightforward. Mass times the specific heat capacity times the temperature change. Alright, so mass times 4.18, that's for water, times the temperature change of the water. Alright, here's the heat gain of the water. This happens to be the amount of the heat released from silver, right? So what we're gonna do is we're gonna just put a negative sign here, and we get a negative value here because this silver block loses heat, loses energy. All right, and this is a Q for silver. How do we get the mass of silver? Well, it's simply Q divided by the specific heat capacity, and then divided by, well, maybe we should move this to the top. All right, divided by the specific heat capacity of silver, and also we need the temperature change. What's the temperature change here? It's the final temperature minus the initial temperature. All right, that's it. On top, that's Q for silver, or you can say it's Q sub silver. On the bottom, this is the specific heat capacity of silver, and this is the temperature change of silver. This is negative. This part on top is also negative. All right, and then in the end you get the mass 106 grams. Two stick figures. We'll take a look at mastering chemistry over here. Q sub silver equals negative Q water. Alright. And they also used this equation. Q is mass times specific heat capacity times delta T. When you use this equation, make sure this Q and C sub S and delta T are referring to the same substance. Alright, when you use this equation. So when you compute Q sub silver, it's M sub silver times C sub S of silver times delta T of silver. And Q of water should be mass of water times C sub S of water times delta T of water. Don't mix up things.